Hi students, in this video we're going to talk more about measures of center and measures of spread and a little bit more with data and statistics. We're really going to focus on comparing two sets of data and what the measures of center tell us about that data. So I wanted just to remind us, we've learned previously that measures of center are values that attempt to describe a typical value in the data set. So in general, this is a number that represents the data. The measures of center are mean and median, and we have previously learned how to find those and what those mean. And then we also have measures of spread. Measures of spread tells us how similar or how different, how varied the data is, tells us how spread out the data is. Measures of spread are range, interquartile range, and mean absolute deviation, which again, we have previously discussed how to figure out range, interquartile range, mean absolute deviation. Just a few things to know that when comparing data sets that I want to make clear to us. Some key words. Variability is the extent to which numbers in a set of data vary or differ from each other. Kind of shows you how spread out they are, how different they are. The word skew is a word that is used quite a bit in statistics. Skew means it's affecting information so that it's no longer accurate. For instance, the mean of a set of data can be skewed quite a bit if there's a number or several numbers that are way bigger than all of the others, or way smaller than all of the others. So those are called outliers. If a number is really larger than everything else in the set, typically it's referred to as an outlier. There is a formula to determine whether something's an outlier, but for now we're just going to say an outlier is something that's very different, bigger or smaller than all of the other data. So those things can skew the mean, but skew in general just means affecting information so it's no longer accurate. And then inference and conclusion, this is the process of drawing conclusions or thoughts based on evidence from the data. So we're looking at the data, we're trying to decide what the data tells us about this set of numbers, whatever it may be, quiz scores or whatever. So inferences and conclusions are basically ideas that or thoughts that are based on looking at the data. I also want to make it clear that you need to calculate the measures of center, the mean and the median, and measures of spread, range, interquartile range, mean absolute deviation, in order to compare data sets or in order to make conclusions. So before we can make conclusions, we have to actually calculate all those measures of center and measures of spread. So we've previously talked about how to do those calculations. I'm going to assume that we can do that. Please let me know if you have questions about those calculations. You will have to do that in order to compare or make conclusions on data. So here are several different things, suggestions, things that I think feel are important on making conclusions and comparing data sets. This would probably be a good time to pause the video and copy some of these notes on this slide and on previous slides, and then unpause it when you're finished. So you don't have to copy it word for word. You can kind of paraphrase and write it in a way that it makes sense to you a little bit. You don't have to copy word for word, but I would pause the video, go back and copy some of these things because you will need these as you are working this week. Welcome back. I hope that you were able to copy all those things. So first of all, I want to make it really clear that the mean is the measure of center that is used most frequently, most often, to describe the data. And it is used as a best representation of the data. That's the mean, the average. However, there are times when the median should be used as the best representation of the data. The median is used as the best representation instead of the mean when the data is inconsistent, when it has outliers, numbers that are really, really larger than all the others or really, really smaller than all the others, has a high degree of variability, so it's really spread out. If any of those things apply, then the mean could be skewed. So it's no longer an accurate depiction of the center of the data or representative of the data. No, it's no longer representative of a typical data value. In that case, we would use the median. Some places, one place in particular I can think of that uses the median quite a bit and not the mean is the level of income for people or salary, the amount of money that people make. Because we have some people who make, outrageous amounts of money, pro athletes, billionaire business people. Those, since they're so much bigger than the rest of us, those high numbers skew the data and skew the mean of a population. So typically, when you talk income, you talk about the median income, the middle income, not the mean income, because it can be skewed. Now, in order to determine if you use the mean or the median as a best representation, you have to calculate the measures of spread because you have to know, is it consistent or is it not? Is it very spread out? Does it have a high degree of variability, of change, of difference, or not? So the measures of spread range, especially the interquartile range and the mean absolute deviation, those are going to tell you the variability and the consistency of it. So if you get a low number when you calculate those, and again, this is compared to the rest of the numbers in the data, if it's a low number for the IQR, the interquartile range, and the mean absolute deviation, means that your data is consistent, that it's close together. So in this case, you could use the mean as a best representation. Now, if you calculate these and you get a high number for the IQR, high number for the mean absolute deviation, or even just one or the other, it tells you that it's not as consistent, that it's more spread out, that the mean could be skewed. So in this case, you would want to use the median as a best representation. So the measures of spread help you decide to use the mean or the median as a best representation of the set of data. Hope that I'm explaining that okay. Basically, we're going to use the mean whenever we can, the most often. However, if the data is really spread out, if it has outliers, if it's not consistent, then we would use the median. Let me show you an example. So here are two class periods. I just made these up at random. Two class periods and their quiz scores. Find the measure of center. I've already done that for you. As you can see, the mean for period 1 is 88. The median is 89. Very close together. For period 2, the mean is 77. The median is 84. As you can see, these are a little bit further apart. Okay, a little bit further apart. If you think you need some practice here on finding mean and median, this would be another great time to pause the video and actually take the data, calculate the mean, calculate the median. Make sure you get the same answers that I did. Now we're going to use this data. So we've found the measures of center. Now let's use it. So again, same data. Which measure of center, should say, best represents the data for period 1? So we're looking at just these. Which measure of center best represents the data for period 1? Well, we always want the mean to be our representative. The mean is the average. We want that to always be our typical value, but we really need to calculate the measures of spread in order to do that. So I'm going to go off to the side and I'm going to calculate specifically the IQR and the MAD, the mean absolute deviation, and the interquartile range. So this is for period 1. When I did my calculations, again, might be a great time to pause the video and do these. So do these for period 1, and then also do them for period 2. If you have forgotten how to find the IQR and how to find the MAD, look back at our previous videos, and that will help you. So for period 1, My calculations gave me an IQR of 3.5 and a mean absolute deviation of 2.3. So for period 1, for this first question here, which measure of center best represents the data for period 1? Well, I can stick with mean because the IQR and the mean absolute deviation are so low. So I would actually write this out in complete sentences. I'm not going to do that just to save a little bit of time in the video, but I would say the measure of center that best represents the data for period 1 is the mean because the interquartile range and the mean absolute deviation are low, which means that the data is consistent and not very spread out. So I'm just going to write so you can see it. We would use the mean, but the justification is based on low numbers for the IQR and the MAD, which means the data is consistent, it's close together. When I did my calculations for period 2, totally different story. IQR was 24.5, the MAD was 13.4. So when it asks which measure of center best represents the data for period 2, these high numbers here, these are high numbers compared to these quiz scores. This IQR is telling us that the middle 50% has a difference of 24.5 points from the lowest in that 50% to the highest. So just the middle group has a difference of 24%. That's 2 letter grades. The mean absolute deviation, meaning the mean of it, the average distance from the mean for all of these is 13.4%. It's over a letter grade on average. So this data is very, very spread out. We can probably identify some outliers here. I think 60 and 54 are both outliers, very lower than all of the others. So the measure of center that best represents the data for period 2 would not be the mean because it's so spread out. Would have to be the median. Median would be a better representation. And again, I would write this in complete sentences, expressing my whole thought and my justification with it. The measure of center that best represents the data for period 2 is the median because the data is so spread out, or because the data is so inconsistent with an IQR interquartile range of 24.5 and a mean absolute deviation of 13.4. So again, the median is a better representation for period 2, and my justification, my evidence, it's all based on these numbers right here. Very high numbers here for the interquartile range and the mean absolute deviation. So I want to go back to it again, just so I can stress the mean is the measure of center that is used most frequently. It's the one that we really want to use, but there are times when we can't use it because it is skewed. It is not really an accurate picture of what's going on. Those cases are when the data is inconsistent, when it's really spread out, when it has outliers, numbers that are really bigger than the others or really smaller than the others. If those things happen, then we would use the median. Okay. And I think we can even go back to our data here. You can kind of see as you compare these numbers for period 1, they're all really, really close. Period 2 is a different story. You got some in the 60, you got a 54, you got something in the 70s, 80s, 90s. You can see that they're far apart. So I know that I said you have to calculate the measures of spread. Sometimes you can tell based on the data set, oh, those are really, really close together. It's going to be the mean. Or those are really spread out. I should probably calculate the interquartile range and the mean absolute deviation just to verify that they're spread out and that they're inconsistent. And again, that would be when you use the median to best represent it. So I know that's a lot. Please let me know if you have questions as you are working on problems this week. We're going to, again, comparing 2 data sets. So best representation is usually the mean, but in cases where the data is spread out like this one, it would be the median. I hope that helps. Please let me know if you have questions. Have a great day.